My name's Charlotte Craig. I'm at the University of Toronto at the Scarborough campus. I'm in the Ecology and Evolutionary Biology department, and I'm doing my master's focusing on how extreme microhabitat temperatures impact insect foraging patterns, specifically focusing on bees. Bees are such a pivotal part of our ecosystem. Humans are extremely reliant on them, as well as bees provide a multitude of ecosystem services. So that's really important as we move forward. So the research is based on a couple of different theories that haven't been tested on insects and bees. So the Bogart effect is one of the pillars of this research. It's the idea that ectotherms, so animals that rely on external temperatures, will preferentially choose microhabitats that best benefit their thermal range and thermal maximums and minimums. So we're going to see if bees choose habitats, so hotter or warmer foraging areas, to maintain their thermal optimum, or if they're not impacted by that at all. The backbone idea being that as climate change progresses, temperatures are going to get hotter, microhabitats are going to get hotter. So by emulating these extreme heat events, we're going to see how bees and other insects might respond.
Understanding how the increase in temperature is going to affect pollination activity in the future it's really important, and it's pressing as well, I think. And so being able to understand how, on a smaller scale, micro-heat hotspots will affect the pollination activity.
So we have Credo sensors, which record temperature measurements and relative humidity at every 1 minute interval over our collection period. So then we can then correlate insect visitation with the plant temperature. We also have a thermal camera that we take pictures of the plants once everything is set up to get the petal temperature. So then we can also correlate that to insect visitation. So we have 6 locations, 2 at the UTSC farm, 2 on campus itself, and then 2 here at the Valley. We chose to do a design in which we bring in our own plants and then pick our own sites that are surrounded by areas that bees and other insects are common in. So what we do now is we bring all of our material to the site, which includes a heater that's used to heat up half of the flowers, and then the other half of the flowers are used as a control so we can see how the insects are foraging in just the normal temperature. We then use bee vacuums or insect vacuums to collect all of the insects that visit both the control and the heated areas. And then we put them into vials, we label them, and then we bring them back to the lab to be ID'd later. We also paint and release other bees that are easily recognizable. So we collect carpenter bees, bumblebees, honeybees, serentinas, and a couple other groups that we can easily recognize. We then paint them with different colors so that we can recognize them when they come back to the plant. And this is a low impact method that we use to see the long-term heat preference of different bees. Once we have completed the research, all of the plants are then going to be planted on UTSC property and will be able to be seen in the valley and provide pollination options for pollinators in the years to come.
I think it'd be really great to understand kind of the underlying relationships between pollinators and these microclimates. With reference to climate change in the future, it's definitely something that's going to be important and going to kind of shape how we're relating to and managing our microclimates, so our homes and our houses and our towns.
I'm seeing increasing numbers of extreme heat events that are due to the synergistic effect of climate change and the urban heat island effect. So just really, really high temperatures that are impacting our bees and humans alike. So this research is really important because it's going to inform many different stakeholder groups, including governmental organizations, conservation groups, and academic circles, on how bees and other insects are going to be impacted by climate change. As climate change progresses, bees are going to be foraging in different areas and in turn pollinating different plants, which will shape how our urban ecosystems exist and function.